Welcome to Pseudoscientific. I'm Darren. Have you ever wondered how apps can send messages to different devices? Thought about why you can still use Google Drive even when it's uploading files? Or maybe you've been looking for a way to add multiplayer to that turn-based video game you're developing. Well, today's topic is about a way to make computer programs talk to each other, even when running on different computers. We're going to be talking about messaging queues. In this video, we'll be covering what messaging queues are, how they're used, and how you can use them in your own code. And stick around till the end for a fun application of messaging queues that you can enjoy and also learn from. Let's start with the basics. Messaging queues are a form of communication between computer programs, where one program, called a producer, sends signals into a data structure called a queue. Here, these signals are stored until the second program, called the consumer, accesses these signals. Computer programs can be both producers and consumers, and send messages back and forth. Messaging queues are just one type of inter-process communication, or ways to share data across multiple programs. There's a variety of ways you can do this. For example, two programs can share info by reading from and writing to a shared file, like Google Docs. However, messaging queues are one of the more effective and popular methods of doing so. Messaging queues have a lot of benefits. First, the two computer programs are able to communicate with each other without the need for both to be active at once. The producer can send a message into the queue, which stays there until the consumer is active again. One example of this is how you can send emails to somebody while they're asleep, and they can receive the email in their inbox once they wake up and check it. Second, it splits a one-part system into separate components that can work together, which makes the system much more versatile. You can even code different components using different programming languages for convenience. This separation of components is called decoupling. Third, by using multiple components, there can be one dedicated to taking input and another to doing a task. By doing this, computer systems can listen to input while performing time-intensive tasks. Due to all of these benefits, systems with messaging queues are quickly becoming more widespread. So let's get cracking on using messaging queues. And in order to do that, we need a message broker, or a software system that maintains the messaging queues 24/7. After all, neither device on either end of the messaging queue needs to be active at any given time, but the messaging queue itself does. We'll be using RabbitMQ on CloudAMQP because it's a free service that allows us to host a messaging queue on the cloud without the need for us to make a server ourselves. While we may be using RabbitMQ, the most widely deployed open source message broker, it's far from the only message broker out there. Apache Kafka and IBM MQ are two other options that are widely used, to name a few. So first, go to cloudamqp.com and click Get Started, and you should be able to make an account right here. Once you've made an account, you should be led to a page like this. Now, click Create New Instance, and select a plan and name. So let's just call this Test MQ. And you can also select a plan, but only Little Lemur is free, so we'll be using that. Then click Select Region. Amazon Web Services works fine. And let's choose Northern Virginia. Click Review, and click Create Instance. Now you've successfully created an instance that you can use for other projects that involve messaging queues. In order to use your messaging queue instance in your code, we first have to get its URL. So click the name of your MQ, and then copy the URL down here. Now you can use this URL to access this specific instance in your code. The details of how to do this are shown on my GitHub code over here, which I'll give a demo of later in this video. And if you want to try using this code for yourself, here's how to do it. So go to colab.research.google.com, which is Google Colab. Click GitHub, and then type in a GitHub URL. So the one that we're going to be using is in here, either Colab Player or Colab Dealer. You'll have to run both in order for the code to work, but the concept of how to add the URL into the code is the same. So let's just use Colab Player for now. The process is the same for Colab Dealer. And now, copy-paste this URL into the search bar. Click the search key, and you'll be directed to this page. Here, you can see something that says replace this, including the brackets, with your CloudAMQP URL. So just copy-paste your URL, and now your code is ready to run. Run this cell first, and then this one. So you can click here to run it, click Run Anyway, and after this cell is done running, you can then run this cell in order to start it. The process is the same for Colab Dealer, so just run both of them, and also another instance of Colab Player in order to start your program. If you want to learn more about Google Colab, be on the lookout for my Google Colab tutorial coming soon. To show you an example of how messaging queues work, I'll be playing two-player bridge online with Vivien, my friend.
It's nice to meet you.
Alright, so we have 3 files open, Colab Dealer and 2 Colab Players, and all we have to do is run the cells to start the game. The instructions for how this game will be played are in the description below.
Okay, so I'm going first and it's asking me if I want to bid. So I put a Y for yes. I plan to win 7 tricks and 7 minus 6 is 1. So I type in 1 for this slot. And then I decide that my trump card will be spades. So I put an S for spades.
Alright, and on my screen, even though we're playing on different computers, Vivien's bid of 1 spade has been sent to me, so I can see that. And now let's say I do want to bid, because I think I can do better than Vivien. I really can't, but like, just for the sake of demonstration. And let's say I want to win 8, so 8 minus 6 is 2. And I'll select, let's say diamonds as my trump.
Okay, now I can see that he bid 2 diamonds. And I decide that no, I don't think I can do better than that. So I put an N for no to end the bidding phase. And then it would go on to the next section. This is an example of the messaging queue system because whatever I type will go back to the dealer and then it'll go back to Darren's computer. So we're able to see what each other type even though we're on different computers.
Mm-hmm. And if we take a look at Colab Dealer, we can see all of the information that's been passed between the 2 players. So here's the 2 hands that we both have. And we can also see the contract, or basically what the final bid was. These links for the Colab Player and Colab Dealer will be put in the description below. That's all for this video. Please be sure to like and subscribe, and share this with a friend if you think they could benefit from this, or if you two want to try out the code that Vivien and I did a demo of. Again, all of the links that we used will be in the description below. See you next time!